Hello. Today we will going to talk about the friction. So we'll understand what is friction. So let's talk about what is friction. Then further we will going to discuss about the types. What are the types of friction? After that, we're going to discuss about the properties. What are the properties of friction? And then later we will going to talk about the few examples. So what are the various examples in order to understand friction more thoroughly? So let's talk about first topic. What is friction? This friction is just that's it. If any two objects they're rubbing on each other, so can we say that is just a friction? Yes, we can say that it is a friction, but let us understand it more precisely. Now, if we say what is friction, so simply we can say that if we are having any object like which is either it is moving or it has the tendency of motion. Again, I'm repeating, if any object is moving or it has the tendency of motion on the rough surface or in some viscous medium like water, air, and many more, so then the motion of the object is opposed, and this resistance is known as the friction. And the force which opposes the relative motion of the object with respect to the surface is simply called as the frictional force. Simply, just we can say that yes, if any object is moving or it has the tendency of motion, either on the rough surface or it is in contact with some viscous medium like water and air, so then the opposition, the resistance, which is provided by the surface, or we can say that the medium, towards the motion or relative motion of the object, simply it's the friction. Okay, so this part is clear. Now let's talk about what are the types of friction. So can we say that, okay, ma'am, friction is just that's it if it is in contact or the object is in contact? No, we can categorize friction in different groups. So let's understand its types. In order to understand the types, let's take few examples or let's do few experiments so that we will understand it properly. Now, the first experiment which we will going to perform is simply, let's say if this is what the table and the surface of the table, and we are having one object which is resting on the surface of this table. Again, I'm repeating, the block is at rest, and we can consider, let's say, if m be the mass of the object. Now the question comes here, is there any frictional forces present over here? If we are assuming, let's say, the small f represents the frictional force, so is any frictional force is present over here? So simply answer is no. There is no frictional force present over here. Now the question comes, why? So simply because that object does not have any tendency of motion, and simply it is not moving because it is at rest, neither it has the tendency of motion. Because of that, frictional force completely zero. Here in this same example only, now if we will apply some force on the block, so let's say if we are talking about the second case, so in second case again we are having the same block only, with mass m. Now we are applying some external force. Let's say capital F represents the external force, and which tries to push this block. But again, the block is not moving. Why? Because some force is acting in the direction opposite to the applied force, that external force. And this force is simply, we can represent with either Fs, is the static friction. So here, simply we can say that yes, frictional force is present. Why? Because the object has tendency of motion. I mean, after some point, it simply breaks away. But this force is trying to oppose the relative motion of the object with respect to the surface. So simply because of that, this object is not able to move. But if we will going to increase the intensity of the force, or the amount of external force that we are talking about, simply this block will move. Even though at this point, at this situation, the object is about to move, and simply we can call this as that the force which tries to oppose the relative motion of the object is the static friction. Now, so I mean, simply we can talk about, okay, this static friction varies from where to where. So the static friction can have the minimum value is less than or equal to 0, and the maximum value is less than or equal to the mu s into n. So now here simply we can write, let's say this frictional force, it will have the value equal to or greater than 0 or less than or equal to mu s into n. So I'm sorry, I think in previous, by mistake, I said it is less than 0. So it will be greater than or equal to 0, or either less than or equal to the maximum frictional force, which is mu s into n. So simply we can say that, okay, F max is nothing but the mu s into n. Now what is this mu s and what is this n? So simply mu s is known as the coefficient of static friction. It is called as coefficient of static friction, and n be the normal force which acts exactly 90-degree, or I can say perpendicular to the object which is applied by the table. If suppose m be the mass of the object, so the normal force will act in upward direction, and simply the weight of the object acts in downward direction, and here the frictional force is acting opposite to the direction of external force which is applied on the block. So simply that frictional force is directly proportional to, simply we can say that frictional force is directly proportional to the normal reaction applied on the block. And in order to remove this proportionality sign, we have taken this constant, which is mu s, and the mu s is the coefficient of static friction. So this is simply one type of friction, which is a static friction. Simply we can say that the first type of friction is static friction, because right now we are discussing about the types of friction. We got one type of friction. Now further, we will carry forward the same example. Now we will going to increase the intensity of external force applied on this block. The same block having mass m, And now we are increasing the intensity of this external force which is applied on the block. Now what will happen? So here the static friction slowly it tends to decrease, and this log will move away. Now that log moves, so again both these surfaces are in contact with each other. So simply we can say that here the force will act, which is nothing but the kinetic friction. So now here we can say that Fk is nothing but the kinetic friction. And again, this kinetic friction, the maximum kinetic friction is given as mu k into n. Simply, it also depends upon the normal reaction applied on the object by the surface. And the mu k is known as the coefficient of kinetic friction. And it is observed that practically the coefficient of kinetic friction is smaller than the coefficient of static friction. So these are the two different types of frictions. One is the static friction, the another one is kinetic friction. Now if we talk about their properties, so properties are like the first important point. So here simply we are talking about their properties. So the first important point comes in our mind that whether the size of the object matters. If suppose we are having the block of same material and everything is same, just that now we have changed the size and we have kept that block on the same surface of that table. So whether the frictional force will going to change? The answer is no. The size of object does not matter, and even the area. Like suppose if initially you have taken the table which has the smaller width, now the width of the table has been increased or it might be decreased, so frictional force will not going to change. So simply we can say that it is independent of size and the area of the object. Now the next one is what? If we change the pair, so yes, definitely if we will going to change the pair, so that means we are changing the nature of the surfaces. So it simply depends upon the nature of surface. So if the surface is changed, so the frictional force will going to change. Generally, smoother surface have the less friction compared to the rough surface, because it totally depends upon the contact area. Because when we say the object is completely smooth, it doesn't mean it is completely smooth. If we talk about the microscopic level, so there are the heads and tails, so only this part is will be in contact with the surface. So it simply depends upon the area of contact, I mean the contact, and it totally depends upon the nature of the surface. So whether the surface is rough or the surface is smooth, so frictional force will going to change. Now the next thing is that if we talk about the kinetic friction and the static friction, the direction of kinetic and static friction, so simply static friction changes its magnitude and direction according to the situation. It may change depending upon the situation, its direction and magnitude can be changed. And in case of kinetic friction, it always acts opposite to the direction of motion. So here we can say that the static friction is the adjustable frictional force, static friction. It is adjustable. And the next one is what, which is kinetic friction. Always acts opposite to the direction of motion. So these are the properties of friction. Now let's take one example. Now here we are having that example. If this is what the monkey, and if the monkey is climbing up with the help of rope, let us consider that m be the mass of the monkey and the coefficient of friction which is acting between the palm of the monkey and the surface of the rope is mu s. So if we have to find out what will be the frictional force, and if we have to find out what will be the tension produced in this rope, or even if the question is asked like which frictional force will act, whether it will be a static friction or it will be a kinetic friction. So let us understand. So simply, now as clearly we can see that the monkey is what, climbing upward. So if m is the mass of the monkey, so simply this weight of the monkey will act in downward direction, so mg with the weight, and the normal reaction will act in upward direction. So like if we will draw the free body diagram, let us consider now this is what the monkey. Okay, so if m is the mass of the monkey, simply we can say that okay, this will be the weight, and as the monkey is moving in upward direction, so the acceleration will point out in upward direction. Now what about the frictional force? Because if we talk about the kinetic friction, the frictional force will act always opposite to the direction of motion. So here, whether the kinetic friction will be there or it will be a static friction. So answer is yes. Here, static friction is acting. Now question is why? Because there is no sliding, which is between, you can say, the palm of the monkey and the surface of the rope. So simply static friction is acting. Okay, so now the question is clear. Okay, there is no kinetic friction is acting over here. Simply static friction will going to act. Now what will be the direction of static friction? Will it be opposite to the direction of motion of the monkey, or it will be in the same direction? So as we have studied the property of static friction, that static friction is self-adjustable force. Simply it changes, or we can say that it adjusts its magnitude as well as direction according to the situation. So in this particular case, that the frictional force will going to act in upward direction, that will be along the direction of the monkey. So now can we write the expression? So here simply, if by looking at the FBD, so if we will write the expression, so it will be given as, which is F minus mg is equal to ma. Further, if we will going to simplify this, because we want to find out the F, where F is the what? Is the magnitude of frictional force. So simply F can be given as what? Which is ma plus mg. We can take m common and simply a plus g. So F is equals to, we are taking m common, where m is the mass of the monkey, and a plus g, provided if we know the acceleration of the monkey, and g is known only, so we can find out the frictional force. Now the second question, what will be the tension produced in the rope? So simply, now here, as the monkey is moving in upward direction, tension will act in downward direction. It will be in the opposite to the direction of frictional force. So we can say that the frictional force adjusts the tension produced in the string. So F will be is equals to T, and which already we have found, which will be G plus A. So I hope with this example, it is clear, I mean, how we can identify whether the frictional force, which type of frictional force is acting, whether it's a static friction or kinetic friction, or if we have to calculate it, how we can proceed. And uh, the quantities, the physical quantities which is related to this, simply we can find out. Thank you so much.